Good morning to all of you.
Good morning, sir.
Yes, sir. Yesterday we agreed upon that ionic bond is formed by a metal losing electron, a non-metal gaining electron. Metal can lose 1, 2 or 3 electrons. Non-metals may gain 1, 2 or 3 electrons. You get a positive ion from metal and a negative ion from non-metal, and that is the electrostatic attraction. The energy released when gaseous ions come together to give a crystal solid is called lattice energy. Lattice energy provides the driving force, all that we know. Whereas between non-metal atoms where electronegativity difference is less than 1.7, you have a covalent bond. In covalent bond, say two atoms, say like hydrogen, they share electron pair. One electron is given by one hydrogen, another electron is given by second hydrogen. The pair is actually shared by both fellows. Sometimes between oxygen atoms, two electron pairs are shared. We call it as a double bond.
Topic formal charge.
And between two nitrogen atoms, three electron pairs are shared. We call it as a triple bond. We represent by three lines. After the sharing of three electron pairs, each nitrogen is getting octet of electrons and happy. It means a covalent bond is formed in three different ways. Between two atoms, there can be a single bond, or there can be a double bond, or there can be a triple bond.
Good morning, sir.
Therefore, the single bond, if you are looking at carbon, carbon can make a single bond with another carbon, or it can make a double bond, or it can make a triple bond. If there is a single bond, distance between carbon atoms appears to be 154 picometers. The distance, equilibrium distance between bonded atoms in a molecule is called bond length. The bond length in CC single bond is 154. If there is a C double bond C, it is 133 picometers. If there is a C triple bond C, it is 120 picometers. As the number of bonds between two atoms are increasing, bond length is becoming short. If you are looking at the bond lengths, that is the distance between two covalently bonded atoms, you can see a pattern. What pattern you see? Let us see. Let us try to see the pattern. We are looking at the pattern. Let us look at these values. Have you seen fluorine, chlorine, bromine, iodine are there in 70th group? FF single bond length is 144. Cl single bond length is 199. Br single bond length is 228. II bond length is 267 picometers. It means down a group covalent bond length is increasing.
Because of that length increasing.
As the size of the atoms are increasing. Also, if you look at HF, HCl, HBr, HI, the covalent bond is there between different atoms called heteroatomic molecules. Even if you are looking FCl, BRI, as you are going down the group, the HX bond length 92, 127, 141, 160. Bond length increases down a group. Have you noticed? Also, you look at if there is a CC single bond, bond length is 154. If there is a CC double bond, bond length is 133. If there is a CC triple bond, bond length is 120. It means as the number of bonds are increasing between atoms, bond length is decreasing. Bond length is a very important thing. We try to see the pattern. Okay, sir? Okay, sir? If two atoms are linked by a covalent bond, half of the distance between the bonded atoms is called covalent radius. So sum of the covalent radius, for example, hydrogen covalent radius plus Cl covalent radius, if I add, I get HCl bond length. Sum of the covalent radii is equal to bond length if there is a single bond. Okay, sir? Bond length means distance between two bonded atoms. Down a group, bond lengths increase. As you are increasing the number of bonds between atoms, bond length decreases. Bond length idea is there only for covalent bond. Bond length is not there if there is ionic bond, because ionic bond is only attraction, electrostatic attraction. Bond length term is relevant only for covalently bonded molecules. You know, covalent bond is there between non-metal atoms or atoms whose electronegativity difference is less than 1.7. You will be wondering, sir, what are the essential differences between ionic bond and covalent bond? What is the difference? Ionic bond is formed by somebody losing electron, somebody gaining electron transfer. Covalent bond is formed by sharing a electron pair. No ions. Ionic bond always forms between a metal which loses electron and a non-metal that gains electron. Covalent bond can be formed between anybody like non-metal atoms, only metal atoms, anybody whose electronegativity difference is less than 1.7. Whenever an ionic bond is formed, there is an electrostatic attraction between a positive ion and negative ion. There is no such electrostatic attraction in covalent compounds. Ionic compounds at room temperature are crystalline solids, whereas covalent compound can be a gas like CO2, it can be a liquid like water, or it can be a solid like iodine. Ionic compounds usually dissolve in polar solvents like water. Covalent compounds dissolve in non-polar solvents like benzene, carbon tetrachloride, carbon disulfide, etc. The aqueous solution of ionic compound conducts current, that is electrolyte current. Whereas covalent compounds like sugar, glucose, if they dissolve in water, the solution is non-electrolyte, cannot conduct current. Reactions between ions are very fast. Reactions between molecules are slow and incomplete. There are many differences between ionic compounds and covalent compounds, as you would see. If they give me NaF, is it ionic compound or covalent compound? I would see that sodium is a
Ionic.
metal, fluorine is a non-metal, electronegativity difference is more than 1.7, so it is ionic compound. If they give me HF, it is a non-metal, F is a non-metal, whatever may be electronegativity difference between non-metals, I can have only covalent bond. What is the bond present between two hydrogen atoms? Covalent. Notice, if the bonded atoms are identical, the electron pair is exactly in the center of two bonded atoms. You are doing a business with your friend, you have given 50,000, your friend has given 50,000, you started the business with 1 lakh, you got a profit of 10,000. How you will distribute the 10,000 profit?
Equally.
You take 5,000 and your friend will take 5,000.
5K, 5K.
That is a justifiable distribution. Suppose your friend is a very bad, cruel, rowdy, dirty rogue. Okay. Then you gave 50,000, he gave 50,000. You got 10,000 profit. He tries to take 6,000 and give you 4,000. Then he will get a little bad name. You get a little good name. Suppose your friend is still cruel. He takes 7,000, gives you 3,000. He is still more cruel and more energies he has. He has influence. He takes 9,999. He gives you 1 rupee. Notice, this is unequal distribution. He says, still we are sharing. No, 1 rupee I have shared. I have not taken all the profit. If the electron completely goes, that is ionic bond. But here it is not completely going. Some sharing is there. So this type of covalent bond where there is some charge separation, due to one fellow keeping the bonded pair close to itself, is called polar covalent bond. The polar covalent bond is also sometimes called delocalized electron pair bond. Delocalized means electron is supposed to be in the centralized locality, but it is going close to one fellow. Polar covalent bond forms between different atoms, heteroatoms, if there is an electronegativity difference. Can you expect H2 bond polar? Can you expect polarity in H2?
No, because same
Can
electronegativity.
you expect polarity in O2?
No.
Can you expect polarity in N2?
No.
No.
Can you expect polarity in S8?
No.
Can you expect polarity in HF?
Yes.
Yes.
If I have HF, HCl, HB or HI, in which case you expect bond to be more polar?
HF.
HF.
Electronegativity of fluorine is 4. Electronegativity of chlorine is 3. Bromine is 2.8. Iodine is 2.7. More electronegative fellow, hydrogen electronegativity is only 2.1. So more is the electronegativity difference, more polarity. Okay. Due to this bond polarity, as the electron pair is going close to more electronegative fellow, he gets minus delta, he gets plus delta. The electrons are flowing away from hydrogen to fluorine. This flow of electrons, if you look at, that results in a little minus charge, a little plus charge. It is not full minus, not full plus. In this polar covalent bond, the amount of charge separated into bond length is called dipole moment or bond moment. Units of charge are electrostatic units. Units of length were centimeters in old scale. So ESU cm is the unit of dipole moment. Modern unit of charge is what, sir? What is the unit of charge?
Coulomb.
Coulomb. What is the modern unit of length, bond length?
Picometer.
Meter.
Meter. Meter is the SI unit. 10 to the power 12 picometers is equal to 1 meter. 10 to the power 10 angstroms is equal to 1 meter. 10 to the power 9 nanometers is equal to 1 meter. But meter is the international unit. So Coulomb into meter. Coulomb meter is the unit of dipole moment. Okay, sir? Let us compare the old units with new units. This is DL is dipole moment. Old unit, charge of electron is 4.808 ESU. Generally, bond length is in the order of angstroms. 1 angstrom is equal to 10 to the power minus 8 centimeters. Suppose you are thinking that bond length is 1 angstrom. Charge of electron is 4.8 into 10 to the power minus 10 ESU. Volt unit. What is the volt unit of charge of electron? 4.808 into 10 to the power minus 10 ESU, electrostatic units. What is the volt unit of bond length? Angstrom. 1 angstrom is equal to how many centimeters? 10 to the power minus 8 centimeters. Are we very clear, sir? Hello?
Yes.
So if one electron is completely transferred, it will not happen. Only partial charge will separate. If you imagine one electron is completely transferred by a distance of 1 angstrom, the dipole moment is equal to 4.8 into 10 to the power minus 18 ESUCM, volt unit. In modern unit, charge of electron is 1.6 into 10 to the power minus 19 coulombs. In modern unit, 1 angstrom is equal to 10 to the power minus 10 meters. So 4.8 into 10 to the power minus 18 ESUCM is equal to 1.6 into 10 to the power minus 29 coulomb meters. In good olden days, this 10 to the power minus 18 ESUCM was called 1 debye. Therefore, I can say 4.8 debye is equal to 1.6 into 10 to the power minus 29 coulomb meters. Coulomb is the charge, meter is the bond length. The product of charge separated into bond length is called dipole moment. Are we very clear, sir? So there is a thing called dipole moment for polar covalent bonds. The dipole moment in HF is supposed to be more than that of HCl, which is supposed to be more than that of HBr, which is supposed to be more than that of HH. H2, O2, N2, Cl2, Br2, I2, P4, S8, all these molecules are supposed to have zero dipole moment. Why? Why they have zero dipole moment, sir?
Because polarity is 0.
Because the atoms are identical. There is no electronegativity difference. But for these molecules, dipole moment is more than 0. Now there is a question. Suppose I have CO2, C double bond O, double bond O. Carbon is less electronegative, oxygen is more electronegative. Therefore, one CO bond is pulling the electrons in this direction. The dipole moment has a direction and also it has some magnitude of charge. Anything
Sir,
that
it's
has a
vector.
direction and magnitude is called vector. This is bond moment mu1. There is another CO bond. It is pulling the electrons like this. So it has mu2 dipole moment. Can you see that, sir? In CO2, there are two bonds. One bond is pulling electron in one direction. Another bond is pulling electron in another direction. Exactly separated by 180 degrees. Suppose you have two girlfriends. One girlfriend is applying force on you in this direction and pulling you. The other girl is pulling you in this direction. Where you will go, sir?
Where, sir?
Both girls are applying equal force. In which direction you move?
No moving, sir.
The
We stay at
resultant of
rest,
these
sir.
two vectors, the resultant of these two vectors is equal to 0 because they are cancelling. What is the resultant of two vectors generally? Whenever there are two vectors, resultant is given by 2p bar cos theta by 2. What is theta, sir? Angle of divergence, angle of separation. Suppose in CO2, because it is a linear molecule, the angle is 180 degrees. So the resultant dipole moment is equal
P
to
represents
P bar represents individual bond moment or individual vector. Bond moment is a vector. Therefore, the resultant overall dipole moment is equal to individual bond moments 2 into individual bond moments into cos theta by 2. They are identical vectors. 2p bar cos theta by 2. Here cos theta is equal to 180 degrees, right? Cos 180 by 2. Cos 180 by 2 means cos 90. What is the value of cos 90, sir?
0.
0.
Therefore, net dipole moment is 0. If two girls are pulling you in opposite directions, net direction you move is equal to 0. Even if you are standing here, two girls are pushing you with equal force in opposite direction. Then also net moment is 0. Yes or no? Yes or no?
Yes, sir.
Yes, sir.
Suppose you are standing here. There are three girls. They are pushing you at 120 degrees. The arrangement is called trigonal planar. Then where you will go? The resultant of three vectors operating at 120 degrees is also 0. They are cancelling each other. Yes or no?
Yes, sir.
Yes.
Yes.
How, sir?
So whenever you have covalent bond between different atoms, if different atoms arrange such that two atoms are linear at 180 degrees separation, or three atoms are at 120 degrees separation trigonal planar, if four atoms are at a tetrahedral disposition with 109 degrees 28 minutes, in all these symmetric arrangements, net dipole moment is 0 because individual bond moments cancel each other. Are we very clear about it? Hello?
Yes.
So dipole moment is what? It is a kind of charge separation, partial charge separation seen in covalent compounds. Can dipole moment be there in every covalent molecule? No. In
No,
which
sir.
type of molecules there is dipole moment? In heteroatomic molecules.
Hetero, sir.
Where the dipole moment is higher, if the electronegativity difference is more. What are the units of dipole moment? Dipole moment is equal to magnitude of charge separated into bond length. So units are units of charge into units of bond length. It means coulombs meters or ESU centimeters. What is the magnitude of dipole moment if one electron is completely shifted by 1 angstrom distance? In world units, 4.8 into 10 to the power minus 18 ESU cm. In modern units, 1.6 into 10 to the power minus 29 cm. What is 10 to the power minus 18 ESU cm was called? It was called as a debye. It is a unit of dipole moment. Dipole moment is a very important parameter. If you take 1,2-dichlorobenzene, if you take 1,3-dichlorobenzene, if you take 1,4-dichlorobenzene, you can imagine a line. This is the angle of separation. It is the angle of separation. It is the angle of separation. Which fellow is supposed to have more dipole moment? Auntie, boy, or chutney?
Boy. Boy, sir.
I don't know how you are judging, sir. The CCl bond is a vector. Electrons are flowing like this. These are two vectors. These are two vectors. Here, what is the angle of separation of these two vectors, sir? 1,4-dichlorobenzene. What is this angle?
180.
This is cos 180 by 2 cos 90. That is equal to 0.
Yes, sir.
Here, what is the angle of separation, sir?
90 degree.
No. It is a regular hexagon.
120.
What is this angle? It is 120. So cos 120 by 2 cos 60. What is cos 60, sir?
1 by 2.
1 by 2.
Yes, sir. So it is 2p bar 1 by 2. That is equal to p bar. Here, what is the angle of separation, sir? It is
60
a
degree.
regular hexagon. This angle is 60. Cos 60 by 2, cos 30. What is cos 30?
Root 3 by 2.
Root 3 by 2. So the
Yes, sir.
resultant is 2p bar root 3 by 2. That is equal to root 3p bar. So in 1,2-dichlorobenzene, dipole moment is root 3p bar. In 1,3-dichlorobenzene, resultant dipole moment is p bar. In 1,4-dichlorobenzene, resultant dipole moment is 0. What is your conclusion?
A, sir.
Yes, sir.
What is your conclusion?
More dipole moment is there in option.
More dipole moment is possible
Lesser the
if the angle, bond angle is least. Yes or no?
Yes, sir.
The lesser is the bond angle, the greater is the dipole moment. Yes or no?
Yes, sir.
Yes.
That's it. That's the conclusion. Okay. So dipole moment is a very, very important parameter of covalent compounds. Because of dipole moment, they get polarity. As they get polarity, they tend to dissolve in water like solvents. And dipole moment can also give you a clue about the shape of molecule. If a AB2 molecule has zero dipole moment, you can think it is linear. If a AB3 type molecule has zero dipole moment, you can think that it is like trigonal planar. If a AB4 molecule has zero dipole moment, you can say it is tetrahedral. These molecules have individual bond moments, but overall dipole moment must be zero. You got the idea, sir? Hello?
Yes, sir. Got
Today
the
we have
Yes,
seen
sir.
the difference between ionic bond and covalent bond. You have seen in a covalent bond, naturally the electron pair, bonded pair must be exactly in the center. But in heteroatomic molecules, there is an unequitable distribution making bond polar. And more is the electronegativity difference between different atoms, greater is dipole moment. Units of dipole moment are in olden terms ESUCM, modern units Coulomb meter. In good olden days, we said that 10 to the power minus 18 ESUCM was taken as 1 debye. You can equate the old unit with modern unit by saying 4.8 into 10 to the power minus 18 ESUCM is equal to 1.6 into 10 to the power minus 29 Coulomb meters. CO2 being a symmetric molecule with an angle of separation 180 degrees has net dipole moment 0, which is given by mu resultant is equal to 2p bar cos theta by 2. The lesser is the value of theta, the greater is the dipole moment. If I look at 1,2-dichlorobenzene, 1,3-dichlorobenzene, 1,4-dichlorobenzene, the first fellow has the highest dipole moment and the last fellow has zero dipole moment. We have seen that. Are we very clear about it, sir? Hello?
Yes, sir.
Sir, in covalent molecules, suppose if I have ozone, how to write the Lewis dot formula for ozone? Lewis dot formula will always focus on valence electrons. Oxygen, which has a configuration like 1s2, 2s2, 2p4, has 6 valence electrons. So 3 oxygens will have 18 valence electrons. Now, to write the Lewis dot formula of ozone, I write 3 O's where the central O is bonded to peripheral O's. At least there should be 1 electron pair between these atoms. Boss, 5 minutes call jasta. Okay. Sir, so out of 18, you use 4 electrons to put at least 1 bond between the oxygens. Remaining 14, you distributed terminal atoms. 2, 4, 6, 8, 10, 12, 14. After distribution, you notice The terminal oxygen is happy, the terminal oxygen is happy. Central oxygen is not happy because it has only 6 electrons. To make central oxygen happy, you should convert any one of the lone pairs into bond pairs. If you do so, you get a structure like this. Here you are putting a double bond. Then it has 2 lone pairs. It has 1 lone pair. It has 1 bond pair and 3 lone pairs. This is the Lewis dot formula. I can write like this. Here 2 lone pairs, here 1 pair, here 3 lone pairs. I can also write like this. See, both are called resonance canonical forms. Now, if you want to find the formal charge, I will write formal charge I want to find out on each fellow in this structure. You should clearly see the electron pairs. Have you noticed that it has 2 lone pairs and 2 bond pairs? Have you noticed? Hello?
Yes, sir.
Hello? Therefore, now formal charge on first oxygen, second oxygen, third oxygen. First oxygen is equal to valence electrons oxygen supposed to have 6 minus number of electrons this oxygen actually has in this molecule. This oxygen actually has 4 electrons as 2 pairs plus it has 2 bond pairs. In these 2 bond pairs, 4 electrons, half of them are belonging to this. Therefore, 6 minus 6 is equal to 0. Formal charge on first oxygen is 0. Let us look at the second oxygen formal charge. Oxygen is supposed to have 6 valence electrons minus. It has only 2 electrons exclusively on itself as lone pair, 2 plus. It is making 2 bonds here, 1 bond here. So total there are 3 bonds means 6 electrons. Out of 6, only half belongs to it. So it is 6 minus 5, which is equal to 1. The central oxygen has plus 1 charge. Oxygen gets plus 1 formal charge when it is making 3 bonds and left with 1 lone pair. Let us look at the third oxygen to calculate the formal charge. Q3 is equal to. It is supposed to have 6 valence electrons minus available electrons. It is having 3 lone pairs. 3 lone pairs means 3 twos are 6 electrons it has plus. It is making 1 bond pair. Bond pair has 2 electrons. Out of 2, half belongs to it. 1 by 2 into 2. So it is 6 minus 7, which is equal to minus 1. It means this oxygen, which is making only 1 bond and has 3 lone pairs, gets a formal charge of minus 1. So in ozone, 1 oxygen has 0 formal charge, 1 oxygen has plus 1 formal charge, 1 oxygen has minus 1 formal charge. As molecules with formal charge are less stable, ozone is less stable. So to calculate formal charge, formula is expected number of valence electrons minus actual number of electrons it has in the molecule. Actual number of electrons it has in the molecule is equal to number of electrons in lone pairs plus half of the number of electrons in bond pairs. Are we very clear, sir? Hello?
Yes, sir.
Are we very clear?
Yes, sir.
Yes, sir.
Somebody wanted me to explain again, I have done it. Should we explain with one more example?
Thank you, sir.
Should we take one more example or close?
Close, sir. Understood.
Thank you.
One
Now,
more example.
one more example, you try using your textbook so that you get clarity. If you don't get it, I make a video for you. Don't worry. I am always there. Now, how many minutes time we have, sir?
4 minutes.
4 minutes.
Very good. Now we are quickly going into the textbook. Sir, today we also need to look at What is bond enthalpy? The amount of energy required to break 1 mole of bonds in a diatomic molecule with one single bond. Half the bond, the energy required to break 1 mole of bonds existing in a homodiatomic molecule with single bond. If you take a molecule like water, the energy required to break first HO bond may be different from energy required to break second OH bond. To break first OH bond, in this example, you are spending 502 kilojoules energy. To break in last OH bond, you are spending less energy, 427. But if you take the total energy required for dissociation and divide with 2, you get average bond enthalpy or mean bond enthalpy. You understood bond enthalpy means it is the energy required to break given bonds. The number of bonds existing between the atoms is called as bond order. In H2 bond order is 1, in O2 bond order is 2, in N2 bond order is 3. In ozone, there is one bond, OO single bond, another OO bond is double bond, but they are fluctuating. Because of resonance, overall bond order is equal to 1.5. How bond order in this type of molecules? Look at how many bonds central atom is making. Central atom is making left side 1 bond, right side 2 bonds. The central atom in overall is making 3 bonds. The number of bonds made by central atom divided by number of atoms to which central atom is locked. So, in ozone, central atom is making 3 bonds and it is bonded to 2 oxygen atoms. So, bond order in ozone is 3 by 2. Bond order is equal to total number of bonds made by central atom divided by the number of atoms to which it is bonded. 3 by 2, 1.5. So, bond order, more is the bond order, stronger is the bond. Are we very clear, sir? If it is not possible to write a molecule with a single structure, we write several possible structures. Like in ozone, we wrote 2 possible structures. The real structure is a hybrid of all possible structures. That is called resonance. Each form is called a resonance canonical form. They don't have real existence. Real molecule is a hybrid of all these canonical forms. Due to resonance, molecule gets extraordinary stability. In carbonate, you can see 3 resonance forms. In ozone, you can see 2 canonical forms. So like that. The resonance stabilizes the molecule as the energy of resonance hybrid is less than the energy of any single structure. Resonance averages the bond characteristics as a whole. Okay. The energy of the O3 resonance hybrid is lower than any individual structure you can think of. Please understand that individual canonical structures have no existence. The overall structure of the molecule is hybrid of all the structures. Okay? Individual canonical forms do not exist. We already talked about bond polarity. We talked about dipole moment. We have said that symmetric molecules have 0 dipole moment. BCl3, which is trigonal planar, is a symmetric molecule with 0 dipole moment. Ammonia is not symmetric, it is pyramidal. So the individual bond moments cannot get cancelled. So ammonia bond moment, dipole moment is not 0.